So we need to check whether our kinetic energy is conserved. So is the kinetic energy initial equal to the kinetic energy final? That's what we need to figure out, is it? Well, this is interesting. We don't know the final velocity. So straight away we realize we've run into a problem. We cannot straight away work out our kinetic energies because we don't know the final velocity. Any ideas what we can do? Momentum. Good. Momentum, what do we know about it? It is always conserved. So if we know the momentum prior to the collision, we know the momentum after the collision. Okay, so our momentum prior to the collision, so let's do our momentum initial is going to be 1 times 10 to the 3 multiplied by 20 because there's no, the bus isn't moving, so the bus has no momentum. So therefore, what do we get? 20,000. What should I use? Kilogram meters per second or Newton seconds? Kilogram meters per second. Good. Because it's not change in momentum. Change in momentum is Newton seconds. Just momentum is kilogram meters per second. But again, you know, that's just the way we do things. If you did that on an exam, they'd be fine either way. So that's our initial momentum, which means we know our final momentum is also 20,000. Now that final momentum is equal to mv, okay, because that's what momentum is. So 20,000 is equal to mv, so v must be equal to 20,000 divided by m. What is m after the collision? Good. Our bus and our car have become locked together, and so it is the total mass of the system, 6,000. So that all cancels. So 20 over 6, 3.33 meters per second. So that is our final speed. So now we have our final speed. We can go back to our initial question. We have our initial speed and our initial mass. We have a final speed and our final mass. So is that kinetic energy the same before and after? Let's work it out. Kinetic energy initially is 1/2 mv squared. So 0.5 times the mass of the car, because the bus has no kinetic energy because it's not moving, multiplied by the initial speed squared. So what's that? That'll be 200,000, I think. So 200,000 joules before the collision. After the collision, our kinetic energy final, so again, 1/2 mv squared. So 1/2 times the mass of both together, 6,000, multiplied by the speed squared. And that, I think, comes out to about 33,333, I think. Is that right? Oh, okay, thank you. 266? Well, 267. Joules. So we have our initial kinetic energy and our final kinetic energy. They are different. So, therefore, we know this is an inelastic collision. We have lost energy. Where has that energy gone? Sound, heat. There'll be deformation in the car and the bus. So energy can go into that deformation as well. But yeah, we know this is inelastic, and so you will often get questions like this on an exam. Examiners love these. Okay? The way to do it is work out momentum first, because momentum is always conserved. Then, from there, once you've got your speeds, you can work out your initial and final kinetic energies. Make sense? Any questions? All right, try the next one.